The following material is for informational purposes only. It is not intended to be and should not be used as a guide for conducting an actual dredging operation. Dredging is a highly regulated and potentially dangerous activity and should only be conducted by a qualified master, crew, and vessel, licensed pursuant to and operating in conformity with all applicable federal, state, and local laws and regulations.
Hi, my name is Tony Dow. I'm here to talk to you about dredging. I've done a lot of deep sea dredging for MARSSAM, for UNOLS, for the United States Antarctic Program. I also am a commercial fisherman and used to work on some famous dredge boats and some famous longline boats. So I've got a lot of time and a lot of experience with things on the bottom. You can call me, a bunch of business cards here. You can get a hold of us through the MARSSAM website, Mud and Rocks. That email is at the end. I come at this from both a science support thing. I also run my own research vessel and my own commercial fishing vessel. So I see a lot of different avenues of this program. I'm available to go on your cruise. I'm also available to talk to you about your cruise. Hopefully we can get you started in the right direction and asking the right questions and find the right people for you, whether that's me or someone else. There's lots of competent people around, but it's hard to know who those people are if you don't know who to call. So you can call the Dirt Dabblers or you can call MARSSAM, Mud and Rocks, and that's our job. We're here for you. If you're on a multiple discipline cruise and dredging is a small component of it, that's no problem. I've run CTDs. All of us have run all kinds of things, multi-cores, piston cores, bathymetry, OBSs, and we get called to do all those things. I particularly like dredging and coring, though. We've got a whole bunch of training videos you can watch, but this is just sort of an overview, and then we'll get into the weeds on stuff later on down the line. So we're starting with the dredges on the bottom because you want to collect rocks. So that's kind of cool. If it's really deep water, there's going to be a significant amount of wire weight in the water column, and that's going to be something that you'll have to attend to on your tensions. And the tensions are all something spelled out on the UNOLS Appendix A. There's a big workshop. There's a lot of this information on the UNOLS website. If you're going to go deep water dredging, you're going to want to get an Appendix A waiver. Talk to MARSSAM about that. We can help you through the process. 1.4 pounds for the steel trawl wire. If you are fortunate enough to use synthetic tension member, then that has no weight in water or negligible weight in water. So you can do a lot of different things, although that's not quite operational yet within the academic research fleet. There are a couple different styles of dredging. There's active dredging and passive dredging, and it really refers to whether the ship is moving to tow the dredge or whether the ship is parked under dynamic positioning and the winch is pulling the dredge to the ship. I used to be a longliner in Alaska commercial fisheries, and basically longlining is all about passive. You throw a bunch of gear out on the bottom and then you come back and try to pick it up, and half the time it's caught on the bottom and you have to get it unstuck. So to me, passive dredging is a lot like bottom longline fisheries, and you get stuck all the time. And the thing about passive dredging is you might get stuck upstream or towards the ship from your weak link. So that's maybe not necessarily a very safe idea. So if you're going to do dredging, maybe not subscribe to the idea that passive dredging is safer than active dredging, or vice versa. There's lots to be talked about there. And we'll get into those weeds later in other videos. Let's see, so we also want to cover, after it gets stuck, how do you get out of being stuck? Lots of times you'll back up on the wire, you'll drive around in a circle. We can show you some screenshots of an actual ship track that got unstuck. But that's a very stressful time when you're stuck. So when that's going on, you need to have your Tums on board so you can eat your Tums and cool your stomach. If your weak link fails, you try to have your weak link rigged up in a way that your side links will fail and you can get unstuck. If that doesn't work and you really actively are stuck and you actually need to cut the wire, usually that doesn't happen right away. You might be there for a day before you decide to cut the wire. That's when you want to bring out the hydrostatic wire cutter. There's a whole module we have on that for watching how to rig that and how to use that properly. When you're pulling your dredge along the bottom, it's deep. There's a lot of tension involved. Safety is paramount. You don't want anyone on deck during that, and you want to physically rope off the deck to sort of remind people someone might be coming out from the engine room on a watch rotation and they don't want to walk through They don't know that you're pulling 14,000 pounds on the wire, and they don't know that it's about ready to break off. So you put a little cone up there and a reminder note on the doors and things like that. The time management during your dredge is important. You want to find out early on in the planning process what speed the winch can go. Can it go 60 meters a minute pay out and 60 meters a minute pay in? Or can it only go 20 meters a minute pay out and pay in? That'll cost you dredge time if you don't ask that question and you budget for a certain amount of winch time and the winch can only go half the speed that you budgeted for, then you just lost half your dredges. So those questions are good to ask early in the process, and at MARSSAM we can help you with all that. Contact us, we're happy to help, that's what we're here for. Mud and Rocks email will follow at the end of the video, you can see that in the credits. The other thing to figure out is when you're on the bottom, do you want to have a pinger on board to let you know how close to the bottom you are, or a beacon on board to let you know not just how close, but also where exactly on the bottom you are. That'd be a USBL beacon. Your ship would have to be equipped with that to operate the beacon, and you'd have to determine whose beacons you're going to use, because it's kind of scary putting a $60,000 beacon right next to the seabed and towing it along in a bunch of rocks. Pinger's a little bit easier and more common to find a ship that's got a Knudsen depth sounder you can use in pinger mode. Those are all questions to be brought up early on in the planning. The pingers themselves are getting long in the tooth, and in the fleet they're sort of going away, unfortunately, because they're just getting really old. But there are a few pingers still around, and you can attach them on the wire. If you're attaching a pinger on the wire, another thing you can think about is some opportunistic science and attach a sniffer on the wire. PMEL has little mapper sniffers, and they'll sniff for different chemicals in the wire. Sometimes those are handy. If your winch breaks in the middle of the cruise and you had a sniffer on the wire, you can go back through your sniffer data and locate all the places that might have been really significant, and then you can go drop a CTD on them, even though you didn't have a CTD planned for the cruise. That might be some way you could salvage the cruise. So doing a little bit of opportunistic science can also benefit you in the process. The winch style that you get given, if you're on a ship that has a drum winch as opposed to a traction winch, it's crucially important that you find out the history of that drum winch, when it was last used, to what depth, and what tension that wire came back on. And we have a nice video here provided by some people in the fleet that will show you what happens if you don't follow up on that drum payout history and you're using a drum winch. And that can end your cruise right there. You also want to find out the history of all the overboard handling systems on the winch. It doesn't have to be that the winch fails. You can also have a sheave fail, or a bearing or an axle fail, or the overboarding system fail, or the A-frame break, any number of things. So you want to find out the general condition of the whole of the overboarding system. That there's lots of UNOLS regs in the Appendix A workbook. That's all online on the UNOLS website. But if you are on a vessel with a traction winch, then it's not quite so strategically important how the wire was wound up on the winch, because the traction head is what's seeing the tension. But nonetheless, there can still be other issues that you need to pay attention to. All the turning blocks, everything needs to be able to take the whole load of it from the traction head out to the A-frame. And you need to be able to have the power to run the winch and run the ship all at the same time. Sometimes you'll come onto a station and want to know what way the wind and sea current and drift in the water column is going. The ship might elect to do a drift test. You have tools at your disposal for that, an ADCP, the anemometers on the ship. Hopefully you don't have to spend hours and hours and hours on each dredge doing a drift test for each single one, because we have that information in the water column with the ADCP. But generally, if you're dredging on seamounts, you're going to want to dredge up the seamount, and so you might need several targets depending on which way the current is going. You might not, in the weather conditions given, be able to dredge on one certain seamount. And the other thing is, if it's in deep water and heavy weather, the swell and the sea state on the ship will be significant on the wire. If you've got 4,000 meters of wire out and it's a big sea running, you might have 7,000 or 8,000 pounds of swell right off the bat. So you're almost using up all your available working load limit on the wire before you even get started. We've got a little Excel worksheet that helps you determine what weak link values to select, and also helps determine what sea conditions you can dredge in and at what depths. And we can work you through that yet in another little module But that's all just for kind of planning purposes. It doesn't substitute for having experienced dredge personnel on board, which is also why you would contact MARSSAM. I'm available for cruises. Lots of other people are available for cruises. And they're going to be more successful if you contact MARSSAM early and start working through all these questions and identifying a ship and a platform that'll work for you. It is important to note when you're dredging, the tension monitoring on the software and the tension monitoring program, usually fed by an LCI 90 from Rugged Controls or Northwest Measurement Technology, that information is being measured on the ship at the A-frame or at the first flag block. That's not the measurement that's not the tension that your weak links see. That's the tension that is the whole sum total of it, including the dynamic loading. So down there on the seabed, you might have used up all your tension already. And on the second page of the worksheet we have for you, you can punch in the numbers and see that you somewhere around 6,000 meters, 6,500 meters, you stop being able to actually go dredging with 3x19 trawl wire if you're complying with all the safety Appendix A regulations. You end up just with no sea state, and you can't pull the dredge off the bottom because you're out of tension limits. So in the past, there have been deeper dredges done, and there have been documented cases where people are exceeding the working load limit of the wire, which is, if you've exceeded this yield strength of the wire, you've now bent the kinky, as Paul Walzak likes to say. The slinky is bent. It still sort of works, but it's no longer the same. That's what happens. You don't want to do that to the 9/16 trawl wire. That's why those limits are in place. We're now under a lot more scrutiny to comply with those, and that's a good thing. We don't want to cut the wire in half with people on deck. But because of that, it's changed from deep water dredging in the past to now the new paradigm. And because of that, the movement is towards dredging with synthetic tension members on traction winches, which hopefully will be a follow-up video to come. One of the fun things I enjoy about dredging operations is it's a big whole ship orchestration. The bridge and captain are putting the ship where you want it, over the target. Your multi-beam techs and science party have chosen the target. You've oftentimes done a little mini multi-beam survey beforehand to find the targets that are going to work for you given the weather and sea state and drift conditions. The engineering department and the deck department have the winch operation and running going on. So you really get everybody involved on the ship, and it's kind of a fun environment, which is good at the start to bring that up and have a meeting, bring all those people together, because there'll be certain things that'll happen. You'll want to change your dredge targets after partway through the cruise, after you learn something from another dredge target, but the ship will want to have a schedule that they know they can run a fire drill in the middle here somewhere, or the engineering department will have a schedule. They want to change the oil on one of the engines, and they can do that when it's a 4-hour dredge time on the other engine because the motion is nice and slow and easy, and they don't need that engine for full speed transport. They only need one engine. So having those conversations daily and being able to present all that and that communication, that's very important and help for a more enjoyable and more successful cruise. Nailed it.